Okay, the next topic is fever. Fever, obviously, we all know is just an increase of temperature. It's also known pyrexia. Exogenous pyrogens is because of infection. Endogenous is, for example, prostaglandin, as you have in here. Inflammation. It has 4 cardinal signs: redness, swelling, heat, and pain. Obviously, the job of inflammation is to stop the infection by, as you can see here, mobilization of the body's defenses, containment, destruction of the pathogens. You have a table in here where you have all the agents of inflammation as well as some of the cells and what they are going to produce. Hyperemia, what happens is that you're going to have more blood, therefore allowing the white blood cells to reach the areas where you have the infection. Containment and destruction. One very important factor is fibrinogen. Fibrinogen is going to start depositing around the area where the infection is, and it's going to form like a lake. The fibrinogen is going to be the borders of the lake. This is going to trap the microorganisms right there in this lake, therefore immobilizing them. And then all the white blood cells that we have are going to go over there, and they're going to start fighting and destroying the microorganisms. The neutrophil is going to phagocytize the microorganisms. When you have an increase of neutrophils, so that's going to be called neutrophilia. Tissue cleanup and repair, basically that is the responsibility of the macrophages. As we said, monocytes are when they're inside the blood. Outside, they're going to be called macrophages. The macrophages will go to the area where the infection was, and they're going to destroy everything. They're going to phagocytize dead neutrophils, dead bacteria, damaged cells. So basically, the macrophages are the ones that are in charge of cleaning up the area where we had the infection. So if we keep scrolling down, so the repair is going to start because the platelets are going to provide platelet-derived growth factor that eventually is going to stimulate the fibroblast to produce more fibers in order to repair the area that was damaged due to the infection. The next topic is going to be general aspects of adaptive immunity. This is the area where we need to talk about antibodies. This type of immunity is going to provide you specificity as well as memory. Specificity due to the fact that the antibodies that we're going to use in here, they're going to be specific for certain type of infections. The antibodies that defend you against poliomyelitis, for example, are not going to be able to defend you against the flu virus. Memory, because obviously once you've been infected with this microorganism one time, this type of immunity is going to give you memory. So the second time that you got the same infection, you don't even feel that you have the second infection, because the response is going to be so fast that you don't have any type of signs and symptoms most of the time, and that is provided by the memories. We keep scrolling down. This type of immunity is based on cellular immunity. This one is the one that relates to lymphocytes T and lymphocytes B. Humoral relates to the antibodies. Let's keep scrolling down then. Based on the way we produce our antibodies, there are different kinds of immunity. The first one that we have in here is natural active. Natural, you got infection on your own. Unfortunately, you got infected with something. And active relates that you created your own antibodies against this infection. Then you have artificial active. Artificial, you did not get your own infection. You got the infection artificially, like for example with a vaccine. And you are active because you created your own antibodies against this infection that was given to you with a vaccine. So that's why it says in here vaccination and vaccine. The next one, which is natural passive. Natural means that you got your own infection. Passive means that you did not create your own antibodies. In this case, your mom created the antibodies, and your mom gave you the antibodies when she breastfed you and you were a baby. The last one that we have in here is artificial passive. So in this case, somebody else got the infection, somebody else got the antibodies, and then doctors get the antibodies from this other person, and they give these antibodies to you because you have the same infection that this other person got. So microorganisms that are going to cause infection, they are going to have antigens, right? Antigen is a molecule that triggers an immune response, as you see right here. Not all the microorganism causes an infection, only certain regions, and these regions are going to be called epitopes, as you can see in here. Haptens are molecules that they are so tiny that they cannot create an immune response on their own. However, if they bind to a macromolecule, now it can initiate an immune response. We scroll down, we have lymphocytes. As we said, we have two main kinds of lymphocytes, lymphocytes T and lymphocytes B. So then you have here the lymphocyte T. All the lymphocytes, like any other white blood cell, is created in the bone marrow. From the bone marrow, it leaves and they will go to the thymus. Lymphocytes T, once they're in the thymus, they learn to identify antigens. However, not all of them are able or capable to do that. Why? Because of different type of problems that these lymphocytes T may have. So therefore, in order to be able to fight the infection, they have to become immunocompetent. Basically, that means the ability to recognize the antigens. What happens if they don't recognize the antigens? That they are just going to be either destroyed or they are not going to be used, and that is called negative selection. So if we keep scrolling down, right here, tells you clonal deletion, energies. This is the one that is talking about those lymphocytes T that they don't work. Positive selection to form clones, because obviously the ones that start working, you need to clone those because those are the ones that work. There are not that many, 2%. The next one is obviously lymphocyte B. I already told you the main job of the lymphocyte B is to produce the antibodies. Lymphocyte B produce antibodies. Antibodies have the ability to bind and identify antigens. And once they bind and identify the antigen, this particular antigen is going to be flagged to be destroyed. That's when the lymphocytes T come to play and they destroy this microorganism.